In this video, we will be learning about principles of isometric projections. So first, what are the objects we see in our day-to-day life? Is an 3D objects, and the drawing sheet is a 2D object. So generally we will be converting the 3D object also into 2D object by using orthographic projection. So it is a 3D object, and if you want to show the dimensions of a 3D object, then what we do is we'll making an isometric, we'll using an orthographic projections, like showing the top view, front view, side view, so that we can understand a 3D object. But in some cases what happens is we need to draw 3D object in order to show that it is a 3D object with the dimensions. Okay. Or else if you have a like orthographic projection, you have from the orthographic projection you have to convert into isometric projections. So from 2D objects, front view, top view, side view, you have to convert into an uh, isometric view of an object so that you can see the all the three sides. Okay. So we'll start with isometric projection. So isometric projection is nothing but the creation of the pictorial drawing of an object. So you have a 3D object, you are creating the same 3D objects by using this isometric projection. Okay. And I hope everyone know what is meant by isometric, because you have learned the term ISO. So first you will be learning the term ISO. So you have learned in your physics that it is isobaric, isochoric, or isothermal you have learned. So if you see the isothermal, it is nothing but the temperature is constant. If you see the isobaric, pressure is constant. So like that, ISO is nothing but the constant or equal value. So here we are giving the constant value, and metric is nothing but the unit to measure. So what are the unit we are measuring? So we are giving that it is a constant. We are giving the constant value for this measure. Okay. So in order to give a constant, so we need to know what which value we have to give the constant. Okay. Suppose I have a 3D object called as a cube. Okay. So this is the front view of a cube. So this is the front view of a cube. If you are looking the cube at the front view, you can see the letters such as A, B, C, and D. Okay. But you don't know whether it is a 2D object, 3D object, whether it is a cube, it is a square, it is a rectangle. You don't know these things. Okay. So it is a square prism, or it is a square pyramid, or it is a cube. You don't know these things when you're looking only in the front view. So that's the reason. Suppose if I'm considering a cube, then I need to make it at an angle. Okay. So this is the angle. If I'm looking at this angle, so I have different points, then I have to give the hidden lines. So there will be the hidden lines here. Okay. So these are the hidden lines where you can see. So already you have drawn A, B, C, D. Then this one will be E. Then this is the F. This will be the G. And this is the H. Okay. So here if you see, we gave the x-axis. Here we gave the y-axis. And here we gave another axis Z. Okay. So there are three axes in order to draw the 3D object. If you are drawing only 2D object, you will be using only X and Y, because you are drawing the 3D objects and you want to make it as an isometric. So what, make sure that it has mutually perpendicular geometrical axis, and it should be equally inclined. It should be equally inclined. So whenever it should be equally inclined, so you know that, suppose this is my, yeah, so it is a circle. So in this circle I am drawing the three axes: x axis, y axis, and z axis. Suppose this is my z axis, then I have to make sure that it is equally inclined. So what I do is I'll take the total three axes. So 360 by 3 I will be doing. So if I divide 360 by 3, then I'll be getting the each angle between the x and y and z, and z and x. The angle will be 120 degrees. Okay. So that's the reason what I have to do. I have to divide this circle 360 degrees into three equal parts. Suppose I'm taking this as my z axis. So with respect to 120 degrees, I have to make an axis of x, and again x and y, the angle should be 120 degrees. Again, with respect to angle 120 degrees, I'll be drawing y. Then this is called an isometric because the it is equally inclined, it is a constant, the angle between them, x to z, angle between x to y, and angle between y to z, it is 120, it is equally divided into 120. Then this we can call it as isometric projections. Okay, so this we can call it as isometric projection here. Okay, so if I want to represent an isometric projection, I have to make sure that the angle, whatever the angle I'm giving, it should be equal to 120 degrees. Okay, so now there are three sides x, y, z. So for these three, I need to make it as an angle of 120 degrees. Okay, so first I will draw same example. What are the cube I am taking? So I'm converting the cube as an isometric view of the object. So this is my z axis. So first I'm drawing one side. This side is A, B, C, and D. Okay. So for this side, I have to make an angle of 120 degrees. Okay. So suppose if you take same one more, I'm explaining once again. So this is my Z axis. This is my X axis, making an angle of 120, and again making an angle of 120, I'll get my Y axis. Okay. So if I draw a horizontal line between X and Y, okay, I draw a horizontal line between the intersection point of X and Y. So already this will be 90. Okay, total angle is 120 degrees, and this angle comes as 30. This angle comes as 30. If I'm considering with respect to horizontal line, then I have to take an angle of 30 degrees. So this will also be become as 30 degrees. Okay, and the internal angle, how to calculate the internal angle? So it is 180 degrees. It is a straight line, so it will be 180 degrees minus 60 degrees, because one side is 30 and one side is 30, because this is 90, this is 90. So total is 120. 90 minus 120 minus 90, it will become as 30. So it will become as 180 minus 60. The internal angle will become as 120. Okay, so this angle will become as 120. So whenever I'm drawing an isometric projection, if I'm drawing the horizontal line, from the horizontal line, the line shouldn't be 0 degrees, it should be 30 degrees in the positive direction, and it is 30 degrees in the negative direction, because we consider the angle counterclockwise as positive and clockwise as negative. Then internal angle 120. So for this case also, if I want to draw the a cube as an isometric projection, then I have to take an angle of 30 degrees, and this internal angle will be, so total is 90 degrees, so 90 minus 30 will become as 60 degrees. Okay, so if I want to represent a cube as a isometric projection, then again here I have to take an angle of 30 degrees. I have to give the same length. So here I am taking an angle of 30 degrees. Okay, and then same vertical line. Whatever the vertical line is, same vertical height I have to give, and then I can join this case. I can join this one and join this one. So this is an isometric view. So this will be 60 and this will be 60, because 120 I'm dividing into equal half. So 60 and 60. If again I draw a line, here, so this will be angle of 30 with respect to horizontal line. It is 30. Internal will be 120, and this will be 30. Okay. So A, B, C, D. Again, I need to draw the hidden lines. A, B, C, D. Next, this will be your E. This intersection point will be your F. This will be your G, and this will be your H. Okay. So this is the actual representation of isometric view, where you can see the front view. So this is my x-axis. So here I can see my front view. Text for x-axis, I can see my front view. So this is my side view, and this is my top view. From if I'm looking from the top, This will be my top view. So in this isometric projection, if I'm taking an equally inclined angle 120 degrees between the axis XYZ, then I can see the three sides clearly. I can see the complete front view. I can see my complete side view. I can see my complete top view here in this case. Okay. Then in the question they'll be asking from the isometric position, draw the vertical position and horizontal position. So what we can see is there are total two vertical positions. So this is a vertical line. So this with respect to this two vertical line, I'll get one vertical position. Okay. And again between these two vertical lines, I'll get one more vertical position. So there are two vertical positions. So there are two vertical positions for an isometric view. We have two vertical position. This is not horizontal plane or vertical plane. This is vertical position. Okay. So this is vertical position. And if you see the horizontal position, there is only one horizontal position. There is only one horizontal position. Okay. So if you look at here, this line and this line 2, 3 and 4, these lines are parallel to each other. Okay. And have same dimension. Okay. And if you see these lines, this 30 degrees, 2 and 3, these are same angle and same dimension we can give. And if you look at this one, a clockwise rotation of 30 degrees, 1, 2, this is the hidden line 2 and this is the 3. Total we can have one more inclination. So these are the parallel lines. Okay, same dimension, same angle, you have three things. Okay, there is one horizontal position because here I don't have any vertical line. In this case I don't have any vertical line, so I can consider this as my horizontal position. So whenever they ask you to draw, they give any hexagon, square, circle, pentagon, they will ask you to draw the vertical position and horizontal position. So whenever you want to make, you have to divide into three equal parts. So whenever you want to draw the vertical position, draw the horizontal line, draw only this part. First draw the vertical line, then take an angle of 30 degrees, and from here take an angle of 30 degrees and join them. Okay. So here you will be getting the one of the view. So this is one vertical position, and again you have to leave some gap, and again you have to draw a line, and from here again you have to take a clockwise 30. You have to take here, you are taking anti-clockwise 30. It is going in anti-clockwise 30. This is going in the clockwise 30. Okay. Then these two cases are vertical position. These two cases are vertical position, and they will be asking the horizontal position. So with respect to horizontal position, again you have to draw a horizontal line. Again this side will be 30 and again this side will be 30. Then complete the square or any of the thing, then it will be completed. Okay. Then here it will be, you have to write it as like a b. In the front you are seeing a, b, c and d. You are looking these things, and if you are looking from this side, here you are seeing the a, here you are seeing the d, here you are seeing the e, and here you are seeing the h. These are the things you can see. And if you are seeing from the top view, here you can see the letter h on this case, letter g, letter b and letter a. Okay, so here you have to take 30 and this is 30, internal will be 60 because total vertical line has 90 degrees. So this is the 30 and internal will be 60. Okay, so this is 30 and this is 30. So internal, obviously internal between x-axis and y-axis will be 120 degrees. Okay, yeah. So this is about the basic explanation of the isometric. ISO means we are taking constant, so that's the reason we have to make it equally inclined. If you're not equally inclined, there are different types of projection like oblique projections and other different projections you will get. If you are giving equally inclined, then it is isometric projection. The angle between x, y, z is 120 degrees because 360 we are dividing into three parts, we will get 120. So angle is 120. And compulsory you have to draw a horizontal line. If you draw the horizontal line, internal is 120, so it will be 30 clockwise, 30 counterclockwise, 30 clockwise. Okay. So this is the basic explanation of the isometric basic introduction. So here if you see, Same explanation, A, B, C, D, G, H. So this, if you draw a horizontal line, counterclockwise 30, clockwise 30, total internal lines will be 120. And you are drawing a vertical line, so it will divide into equal half, 60 and 60. So these are the three axes, X, Y, and Z are intersecting, are making an angle of 120 degrees with each other. Okay. So again, if you draw a horizontal line, it will be 30 degrees to the counterclockwise direction, 30 degrees in the clockwise direction. So totally will be completed. And this is an angle of 30 degrees. Okay. And whenever you see a square, whenever you see a square, so this distance is, suppose this is a square 40, example, a square 20, example, a square 20. So this is a distance of square 20. So if you make orientation like this, or else if you make an orientation of 30 degrees, so this is the orientation of 30 degrees, same square, the length will be increasing. And suppose if you are taking an angle of 45 degrees, if you're taking an angle of 45 degrees, then you get the maximum distance, which is nothing but the true length, which is nothing but the true length. So if you measure the angle, this angle comes as 45 degrees, 45 degrees. So whenever you rotate a square orientation, then at the rate, at the, if you give an inclination of 45 degrees, then you can find the true length. If you give exactly 90 degrees, or this is my 90 degrees, if you give 90 degrees, it will be have very less. If you give 30, it will be increasing slightly compared to this 0 degrees, compared to this 0 degrees line, it will be less. And compared to 0 and 30, 30 has more diagonal length, and this 45 degrees has the true length. Maximum length is the true length. So maximum length you can see in the 45 degrees rotation. So that's the reason we'll be comparing the true length to isometric. So this is my isometric length. For this isometric length, I'm giving a inclination of 30 degrees, but this is not the true length actually. So that's the reason we have to calculate what is the reduction length. So this is my 45 degrees line. If I measure this one, this is my 45 degrees line, which is the exactly like a rhombus shape, and it has the true length. This distance is the true length distance. Similarly, if I take rotate it as for 30 degrees, so this is my 30 degrees line. So the length will be reduced. So what is the reduction of the length? I need to calculate. So this is a 2 marks question. It can be asked as a 2 marks question, which will be discussed in the next slide. Okay. So the angle is 30. This angle is 45. So there are two triangles. One triangle is triangle P, B, and O. PBO at and making an angle of 45 degrees. And there's another triangle, triangle ABO. Okay. There are two triangles, triangle PBO and triangle ABO. There are two triangles making an angle of 45 and 30 degrees respectively. And here we need to calculate 45 length is the true length of the square. So with respect to this true length projection, what is the, with respect to this true length projection, what is the reduction length compared to 30 degrees? You have to calculate. So you have to use trigonometry formulas. So in triangle ABO, so we are taking the BA, we are taking BA by BO. Okay, we are taking BA by BO equal to 1 by cos 30, because we considering uh, it is the angle is 30 degrees. So BA by BO equal to we are using trigonometry formula. BA by BO comes as 1 by cos 30, and we are to finding the value as, it is cos 30 is root 3 by 2, so 2 by root 3 will be there. Now I am considering the angle PBO. So here BP by BO, BP by BO equal 1 by cos 45. So cos 45 is 1 by root 2. So here it will comes as reverse because it is inverse. So root 2 by 1. So now I need to calculate what is the reduction length. It is nothing but this is the smaller length and this is the maximum length. BA by BP I need to calculate. So here uh, if I make the calculations, BO and BO get cancelled. The value of BO and BO get cancelled. So BA by BP value comes as So BA equal to BA by BO, BP by BO. BO get cancelled. The value comes as 2 by root 3 multiplied by 1 by root 2, because it is inverse. Again we have to make it as inverse, so 1 by root 2. So here I multiply by root 2 and to root 2. Okay, so here I'll get by root 2 by root 3. I'll be getting root 2 by root 3. I'll be getting in this case. Okay, and here then the root 2 by root 3 value comes as 0.815. Okay, so this is the ratio we are taking. Isometric length, is nothing but BA, and true length is nothing but BP. So isometric length by true length, BA by BP equal root 2 by root 2 by root 3, and the reduction is 0.815 or 9 by 11 is the reduction. Okay, so if I want to draw the isometric length with respect to true length, it should be reduced by 0.815, then only I can see the isometric projection. Therefore for the isometric projection, the reduced ratio is 0.815. Okay, so there are two terms, isometric projection and isometric view. So whenever we are making isometric projection, because we are rotating at an angle of 30 degrees, compulsory we need to reduce the length to 0.815. Whenever we are seeing the isometric view, then no need of conversion, it should be true length. That we'll be seeing in the next slide. So whenever I'm projecting an isometric projection, whenever I'm making an isometric projection, I need to reduce the length by 0.815. And whenever I'm drawing the isometric view, then I need to take it as a true length. Therefore isometric view is larger compared to the isometric projection. Isometric view is always larger compared to isometric projection. So this is a representation from the textbook. So it is a rectangle. This is a rectangle having a height of 50. So length is 30 and width is 15 and the height is 50. Okay, so similarly if I'm making isometric projection, so what I have to do is I have to multiply 30 into 0.85. This value is 30 into 0.815. Similarly this one I'm multiplying into 50 into 0.815. This one also I'm multiplying into 0.815, but you shouldn't be representing you reduce the length by 0.815. Just write the term as isometric projection. Therefore we can understand that it has been reduced the length of 0.815. And whenever it is an isometric view, no need of reducing any length, just take an angle of 30 degrees and take the true length 30, 15 and 50. Same thing you can, but here same, take an angle of 30 degrees, then 30 multiplied by 0.815 and 50 multiplied by 0.85, 15 multiplied by 0.815. You have to do this case. Okay, isometric projection is a lesser dimension compared to isometric view. In the problem they'll be asking either isometric projection or isometric view. So you have to look before starting the problem. Compulsory you have to check whether they are asking isometric view or isometric